This is a video presentation of my master thesis. I developed a method for procedurally generating narratives for video games. The project consists of two parts: the story engine that will generate the story and the game that will execute the story. The generated stories follows the hero's journey. He will start in the ordinary world. Some kind of event will force him to leave the ordinary world and enter the special world. Here, the main part of the game will take place and end with a final boss battle. Most games end here, and to keep the scope of the project limited, so will the stories generated by the story engine. The story engine works in steps. I will briefly explain some of the most important steps. The first step is to find a reason for the hero to leave the ordinary world. To do this, we generate a chain of events that takes place before the story in the game and ends with an event that would force the hero to enter the special world. This is done by having a list of events. I call them actions, and with each action is a list of associated consequences. A consequence can either be another action or it can be an effect. An effect is an event that would force the hero to leave the ordinary world. The algorithm works by taking a random action as a starting point for the chain. For instance, the king dies. Then it takes a random consequence for that action. For instance, the throne successor is kidnapped. We add this event to the chain, and because it's an action, we pick a new consequence associated with that action. For instance, civil war breaks out. This is also an action, so we pick one more consequence. For instance, one of the hero's loved ones is kidnapped. This is an effect that would force the hero to leave the ordinary world. The next step is to find the opponent and his motivation. When looking at the actions from before, we see that some of them is caused by people. So for each action that is caused by a person, we associate that action with that person and a list of possible motivations. When finding the opponent, we simply take the chain of events from the step before and go back till we reach the first event that are caused by a person. He will then be the opponent, and we pick a random motivation out of the possible motivations for that action. At this point, we know the events leading up to the beginning of the story, we know the opponent, and we know his motivation. The next step is to find out how the story would play out in the game. To do this, we use a modified form of generative grammar. To understand generative grammar, let's consider the following rule. A sentence can consist of a noun phrase followed by a verb phrase. Another rule says that a noun phrase consists of a determiner and a noun. And a third rule says that a verb phrase consists of a verb and then a noun phrase. Rules like these can be used to generate grammatically correct sentences. And as we add more rules, more and more complex and variated sentences can be generated. A similar set of rules can be used to describe the syntax of a story. We know that a story follows the stages of the hero's journey. In our case, we use a slightly modified version of the hero's journey, adapted to storytelling in video games. So the first rule is that a story consists of the ordinary world, then the call to adventure, then meeting with the mentor, then crossing the first threshold, then test allies and enemies, then the approach to the innermost cave, the final ordeal, and finally the reward. Let's, as an example, look deeper into crossing the first threshold. We can have two different rules for this. The first rule is that crossing the first threshold consists of meeting the threshold guardian and then leaving the city. It can also be leaving the city and then meeting the threshold guardian. When generating the story, we only choose one. Meeting the threshold guardian can have multiple rules. For instance, it could be a conversation, then a battle. It can be a conversation, then a puzzle. Or it might be a puzzle, then a battle, just to name a few. When generating the story, we only choose one rule from the list of possible rules to apply. Adding more and more rules will allow us to generate more complex and variated stories. Stories are exported in XML format so that they can be read and understood by a game. To test the quality of a story and how much procedurally generated narrative would affect replayability of a game, I implemented a game so that test participants could play the stories generated by the story engine. At the moment, the game can only play one fixed story and it cannot understand new stories. The game and story was tested on 29 test participants and evaluated based on the results. The results showed that the story engine in its current state does not produce stories that are long and sophisticated enough for the players to really get involved. The test results are inconclusive, but they do suggest that procedurally generated narratives increases replayability.